let's take this moment to do a different type of lesson for today. I had a quiz planned, but let's try this. Okay. So, and we'll use this on Wednesday. So I want you to write an ACE chart. Now this ACE chart is really weird because I want you to try to make your first, when you do it, make your first column your smallest one. All right. And then your next two columns, make those your larger ones. Okay. Let's try that. And you pause the video while you do so. Okay. At the top, the first column, I want you to write type. Oh. Let's zoom in. All right. The first type we're going to talk about, of course, GCF, right? Greatest common factor. All right. Now, that second column title will be what it looked like. Oh Lord, that sounds like I'm saying something else. All right. Anyway, what does it look like? That's what I should have said. All right. Now, when you're dealing with greatest common factor, put your little star and write it can have any number of terms. It can have when you do greatest common factor, you can have any number of terms. All right. Now, next one. The number of terms you start with will be the same number of terms left the number of terms we start with will be the same number of terms that will be left over in the parentheses. All right. For instance, let's do it for instance. $6D to the fourth plus 4D to the third minus 6D to the second minus 4D. All right. You won't ever lose a term by doing greatest common factor. When you do your parentheses, when you do greatest common factor, you will pull out X amount, right? But you will still have 4 terms left in the parentheses. All right. They're just, like I said, you're trying to get it for a cheaper amount. All right, let's keep going. Next bullet. Now, In order for you to do greatest common factor, all the terms, all terms must have a common factor. All the terms in that polynomial have to have a common factor for you to do greatest common factor. Now, they may be common in number. Now, when I say number, I'm talking about the coefficient or constant. All right. When we say number, we're talking about both coefficient and constant. So they have to be common in number, or they can be common in variable. Now, they also could be common in both number and variable. All right. Let's revisit that 6D4. Let's revisit that. All right. So in that problem, 6D4 plus 4D to the third minus 6D to the second minus 4D. All right. If we look at the coefficients of each term, there's one factor I know that they all have in common. All these are divisible by 2. A 2 will go into all these. That's the largest number they have in common. A 2. So they are common in number. So as soon as we know they're common in number, you can go ahead and draw your parentheses. You can do greatest common factor. You can do greatest common factor. Now, let's look at the letter. Are they common in variable? I see a D here, a D here, a D here, and a D here. All 4 have a D. So yes, they are both common in number and variable. So let's go ahead and do it. So we know that the 2 will come out. And the most amount of D's we can take from everybody is what? 1 of the D's. Now we divide to see what's left over. It'll be 3D to the, is that a 9? That's a 4. Okay. 3, 2D to the second, negative 3D, negative 2. And that's greatest common factor. That's all greatest common factor will require you to do. All right. Now, let's talk about when to look for greatest common factor. Let's finish this up about when. When should you look for it? Okay? Always. 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 Always look for greatest common factor. Always look for the GCF first. Always look for that first. Look for that first. All right. Let's move on. All right, so since we're done with greatest common factor stuff, let's now move to write this down on the side over here. Trinomials when a equals 1. All right. Now, you said, what does it look like? Well, it has to be, all right, we'll do this. First, you got to have a trinomial. This will not work in any other polynomial. It has to be a trinomial. And when I say trinomial, it has to be like x squared has to be your highest exponent on the variable. And when it looks like that, there has to be there is a 1 for let me make this bigger. There we go. There is a 1 for the coefficient of the a term. You know, x squared, something squared. All right, you have to have a coefficient of 1 for the a term. Now, for this one, I'm gonna fix my little win for a little note. Okay, let's come over here to the next column. Yeah. All right. Do this. Find factors of C that combine to get B. All right, remember we did our all right, and we said that our C is here and our B is here, and whatever satisfied that, you put the factors here on the side. All right, and those factors are what goes in the parentheses. You know, you put the first factor, you can put it here, and the second factor, you can put it there. All right. Yeah. Yeah. Okay. That's pretty much straightforward with that. All right. I guess I can give an example here. Let's do an example here this time. Let's do d squared minus 18d You know what? I got a better one. Not this time. D plus 45. All right. So it is a trinomial. And if I look here in the front, my A term is 1. So I saw one student wants to have the 1 there, they'll go ahead and do this. All right. Draw your parentheses and go ahead and draw the cross. I'm cool with that. All right. So C is 45 and B is a negative 18. And it says find factors of C that will combine to give you B. So C is 1 and 45. You get 9 and 5. You have 3 and 15. And I think that's about it. All right, now, there's nothing we have here that will combine to give us, say, negative 18. So, what's another way to multiply to get a positive number when using factors? We know a positive times a positive give you a positive, but what else would give you a positive when you multiply? 2 negatives. Negative times negative. Now, which one of these factors will combine to give us negative 18? Right here. So the two factors, it doesn't matter where you put them. The two factors are negative 3 and negative 15. And that's what goes at the back of your parentheses. All right, negative 3, negative 15. What goes in the front? What variable did you start with? D. So that goes in front of it. That's it. All right, let's keep going. Let's keep going. All right. Next, we're going to talk about, let's go ahead and break this line up. Let me go ahead and do that too. All right. Next, we're going to talk about let's study or work on a few of the basic problems. Remember, greatest common factor and factor trinomial is going to be your bread and butter for this lesson. So let's do it. Let's do a couple. All right, so the first problem we're going to work on is, let's try this one. Looks kind of weird, but let's do it anyway. Oh, let me add something to it. All right. Now, when should we try to factor using greatest common factor? If you said sometimes, if you said sometimes, F. All right. So here we go. I think the 7s and 56, I think they do have something in common. Because 1 times 7, and then we have 1 times 56, and 7 times 8. All right. And as far as I see x's in both, I see y's in both. I see 2 x's here, 5 y's here, 2 x's here, 4 y's here. All right. What factor do we have in common? The highest one in number is the 7. What's the most amount of variables you can get from everybody? I can get 2 x's from both, and I can get 4 y's from both. So we need a parenthesis. And remember, we're still going to have 2 terms. They'll just be, the coefficient will be smaller numbers. All right. So we said that we're going to pull out a 7 x squared y to the 4. All right. Let's scoot that over. 7 x squared and y to the 4. All right. What's left over? 7 divided by 7 is 1. And we have no x's left over. We only have a y. All right. 56 divided by 7, or we take out the 7. We have a plus 8, positive 8. We took out both x's, and we take out all the y's. That's it. That's it. Now, we can't keep factoring because the next type of factoring I showed you was how to factor trinomial when a is 1. This in here that's left over is not a trinomial. So you're done. All right, let's keep going. Let's keep going. Let's try another example. Let's try, oh, no, let's not do the same one with the same numbers. Let's switch the numbers. Let's try. Now, if you have a problem and it cannot be factored, there's nothing wrong with writing prime. All right. Now, what's the first type of factor we should always try? Greatest common factor. All right, let's do it. Go to our smallest number, which is 16. Let's check for common factor in number. So 1 and 16, 2 and 8, 4 and 4. 24 is also 1 and 24. 2 and 12 is 2 in there. Let's check for a 4. There's a 4 in there, 4 and 6, and let's check for an 8. 8 and 3. I'm only using my smallest factors. My factors are my smallest coefficient for 24. And I know both of these are 16, so these are going to be the same. All right. What is the largest number or the largest factor we have in all 3 of those numbers? 8. All right. Now let's look at our variables now. I have 9 x's. Not going to draw 9 x's. You can. So if I got 9 x's here, 6 x's here, and 3 x's here, what's the most amount I can get from everyone? I can get 3 x's from everybody. So I'll just put that down. I can take out 3 x's, and I'm going to circle. I'm going to take out 3 x's from everyone. Let's look at the y's now. All right. I see 9 y's here, 7 y's here, and 2 y's here. What's the most I can get from everybody? I can get 2 y's from everybody. Now draw them out if you need to. All right. Now that we say they all have something in common, you draw one big parenthesis. Now we're going to still have 3 terms in here. They'll just be smaller amounts of everything. Well, the stuff that's in common. We said we're going to pull out a 8 x to the 3rd And let me and y to the second. That's what we were taking out. All right, let's divide to see what's left. 16 divided by 8 leaves 2. We said we're taking out 3x from everything. So that's x to the 6. Taking out 2 y's from everything. So that's y to the 7. Negative 24 divided by 8 is a negative 3. We're taking away 3x from everything. So that's x to the 3rd. Taking away 2 y's from all the y's. So that's y to the 5th. And the last term is negative 16 divided by 8 is negative 2. We took away all 3 x's and all 2 y's. If you look back at your problem, you have nothing else in common. All right. So now, we have 3 terms left in this parenthesis here. 3 terms. It is a trinomial. But what's the degree of the first term? 13. That is not an A term. Remember, your A term, your highest degree in your whole polynomial must be 2. So there's no more factoring for this. Aren't you glad? All right. Let's go to some more problems now. Remember, this is just a base. Come on now. Stop. This is just a basis for the basis. Remember, greatest common factor will get you a 35%. Let's work on the other 35. R squared plus 6RS, stay with me, minus 40S squared. All right. Now, this is a trinomial, right? It is. And my A term is already in standard form. All right. My highest degree in this whole thing is 2. And it's already in standard form. My A term, or my coefficient of my A, is an understood what? 1. So this is a trinomial where A equals 1. When A equals 1, like I said, I saw one student that came on and put their parentheses in the problem, getting ready. And then they drew their X. Up under that, I have no problem with that. I'm good with that. All right, let's do it. Now, what goes at the top of this? Negative 40. Don't worry about the RS and all that. I got you. And then what goes at the B? 6. All right, now, what factors multiply to get negative 40 but also combine to get 6? Let's do the factors of negative 40. 1 times 40. 2 times 20. 4 times 10. Is that it? And 5 times 8. All right. Now, while all of these will give you 40, none of these will give you negative 40. So remember, in multiplication, remember the triangle. To get a negative number, you have to have a negative and a positive. In multiplication, to get a negative product, a negative answer, you have to have a negative and a positive number. So one of these numbers in each factor have to be negative. So if you don't know which one, look to your B term. If your B term is positive, then your largest factor has to also be positive. So that means the smallest must be negative. All right, now, which one of these factors, when you add them together, combine, will also give you 6? This one. So here we go. Negative 4 and 10. And my students said they just plug it in right here. I have a problem with that. Minus 4 and Since it's a positive 10, say positive 10. Now, let's talk about the variables. Now, we know r is going to be in the front because r times r is r squared. Now, remember, the last two numbers will also be multiplied together. See, negative 10 and negative 4 and negative 10 is what gave us negative 40. So what variable is this? S. All right, that's it. If you don't believe me, multiply it all back and you will get r squared plus 6rs minus 40. All right. Thought I'd put that one in for you. All right. So on the test, just completing greatest common factor and factoring a few trinomials will get you a 70. So two greatest common factor, two trinomials. That will get you a 70. 35, 35. All right. Now, for an 80, add 5 more points to that. We'll look at something like this. See if we find a big. Let's try something like this. Let's put them together. 5 more percent. 5v squared plus all right, 55v plus 150. All right. All right, let's do it. So, in this problem, we have to first look for greatest common factor. We didn't. Now, the other trinomial, we saw the a was 1, so we didn't worry about it. But when you have a trinomial and your a term is not 1, greatest common factor. We got to see what's going on with it. All right, let's do it. I say just try it always. Try greatest common factor always. All right. And I'll show you another one that comes up. Anyway, so we look at our smallest number. That's why you look at 150 like, golly, but don't worry about it. If you start at the smallest number, you'll be all right. So 5 is 1 times 5. We're only going to look for 1 in 5. All right. So 55 is 1 in 55. And then 5 goes into 55 11 times. So 5 times 11. Done. 1 in 150 is 1 times 150. Sorry, 150 is 1 times 150. 5 goes into 150 30 times. So 5 times 30. See there? Done. The largest number you see in all three coefficients is 5. All right. There's nothing else left in common. So we don't have any b's in common. So we go right along. And greatest common factor parentheses, that's only 1. And we're going to pull out a 5. What's left over? 5 divided by 5 leaves the v squared. 55 divided by 5 leaves 11v. 150 divided by 5, that leaves 30. Now, look inside the parentheses. We need to see if we can go a little further with that. In parentheses, we have a trinomial, and your a term is 1. So now we have to, since your a term is 1, you can go on and draw you a pair of parentheses and your cross. All right. Now, what are you going to put at the top of the cross? What's your C term? 30. What happened to my writing? All right, 30. And then at the bottom here, what's B? 11. Everything positive, so your factors will be positive. So what factors give you 30 to also give you 11? We know 3 and 10, 1 and 30, 5 and 6. Which one of those combine to give you 11? 5 and 6. So 5 here, 6 here. All right. So the only thing we have to do is put the 5 and 6 in the back part of this parenthesis. And since it's positive 5, we'll say plus 5. Since it's positive 6, we'll say plus 6. And what letter goes at the front of this parenthesis? Since we're looking at a term is v squared, v here, v here. Now, don't forget, there's somebody that was in the problem from the beginning. This 5. Put them back. Because without this, the answer is not complete. Those 3 types of problems there will give you an 80 on the test. Isn't that generous of me? Okay. I need you to practice.